expressions are what we're covering. And remember, rational just means a ratio. That's all it is. And so when we see rational, we're thinking a ratio. So we are looking for an equation or an expression that's as a fraction. That's all it is. And so when we can diagnose the vocabulary that we're using and take it down to something that feels really overwhelming to go, can I work with a fraction? Absolutely. We know how to work with a fraction. So what we're going to learn in this chapter is we're going to learn how to simplify a fraction. We've learned to simplify fractions since we were in 4th grade. So now we're going to simplify them but add variables and maybe even binomials in it. Okay, so we're simplifying fractions. We're going to add, subtract, multiply, and divide fractions. Again, concepts that we have learned in 4th, 5th, and 6th grade for it. So all the same rules apply because we haven't changed any of those math rules. And then we're going to see what the graph of that looks like. So that's kind of our big picture of where we're headed. So today specifically, we are going to cover simplifying them. We're going to cover adding and subtracting and multiplying and dividing. All right? Okay. So basic rules of fractions. So a lot we're going to harken back to what did we learn in 4th, 5th, 6th grade with fractions and how can we apply what we know to what we don't know. Right? So let's go back up. So again, rules about fractions, it doesn't matter what's in the fraction, it always remains the same. So fractions always have to have a common denominator if we're going to add or subtract them, right? You can only cancel like terms from the top and the bottom if they are attached by multiplication, right? So if we have something that is x plus 2 over x, we are not allowed to cancel those guys out because this one is attached with an addition sign for it. So those are our basic final rules that we are working with. If we remember those, we know everything for this. Okay? So hopefully a lot of this feels intuitive.
Is some of this on here?
Yep. So we're going to work through all of our notes that you have printed off. Okay. So the very first thing is we know that rational expressions are just a ratio. So at the top it says a ratio of two polynomial expressions. So we've gone from a ratio or a fraction. You can put in that blank either ratio or fraction. That we have a numerator and we have a denominator. Okay. So when we simplify a regular fraction, we've got our numerator on the top, our denominator on the bottom. We would say, what factors do they have in common, right? So we might write it out as our individual factors and go, oh, there's a 2 on the top, a 2 on the bottom. We are canceling this because that's really creating the number 1, right? And we don't have to write the number 1. And we can say, okay, that simplifies down to 5/6, correct? Right. So if we look at a fraction that actually has variables, the same thing, we write it out. So we would have, this is really 4 times a, and on the bottom we have a times a. As long as we have multiplication, then we can take them off, right? So we have an a on the top, an a on the bottom. That's really the number 1. So we can erase him out, and we are left with 4a over it, okay? So anytime we have fractions and we have a monomial, mono meaning?
Is it more than, it's just 1?
1.
Okay.
Mono meaning 1. So meaning that the term on top doesn't have anything added or subtracted to it. It's just one term by itself. So a monomial on the top, a monomial on the bottom, we're just going to use our exponent rules and our multiplication and division rules, right, to cancel it out. Okay, so here's an example. And this is on your notes too, but if we start with 20x to the 6th over 14x squared, out to the side, we've written out the factors on it. So 2 times 10, and then all 6 of the x's, 2 times 7, 2 of the x's here. We could simplify 10 into
2 times 5.
2 times 5, perfect. Okay, if we wanted to break it out. But all we're doing is looking for, can I find something on the top that I can cancel with on the bottom? So we've got two 2's that can cancel. This is the number 1. We've got x's, x's. And so what do we have left? Once we've canceled everything, we have left over on the top
10x to the 4th.
10x to the 4th, and on the bottom
7.
7. Okay? So while it's not down to one singular term, there's still a fraction bar. It is fully simplified as much as it could be. All right? So let's work this bottom one. 4ab squared over 15ab cubed. So we have the option. We can write out all of the factors, or we can use our exponent rules. Okay? So remember with our exponent rules, it said if our base is the same and we are dividing, what do we do to the exponents?
Subtract.
We subtract them, right?
Mm-hmm.
So between a squared and a, I would have 2 minus 1. So I'm left with just an a, right? A to the 1. On this one, we've got 2 minus 3. So what does that give us for our b?
-1.
-1. Okay, and then we've got 4 over 15. Now, is there anything that we can simplify between 4 and 15?
No.
Because 4 is 2 times 2, and 15 is
3 times 5.
3 times 5. They have nothing in common, so they're just going to stay. Do we like to leave a variable with a negative exponent?
No, so it'd be 15b on the
Okay.
bottom.
Right, because the negative exponent says I need to
Change signs.
change sides. Perfect. Right, so we're going to move him from the top and move him down to the bottom. We've got 4a on the top and 15b left on the bottom. Right? All right, so monomials are really simple. We're just finding the factors, canceling them out. Binomials can look a little different. So binomials means, remember, means 2. So we have 2 terms that make up something. So we've seen that when we were foiling or unfoiling, factoring, all of that. So we have a variable and a constant, right? So 2 different terms that we are either adding or subtracting together. We can't combine them because they live in different families for it. So when we're simplifying a binomial, we can multiply binomials together. So our point of multiplication is in the middle. And so we can look at an entire binomial as one grouping that we can take out as long as it's attached to the multiplication, but we cannot separate the values that are within it.
Okay.
Am I making sense? All right, so as we are looking at binomials, we are trying to find all the common factors of it, which means that we might have to factor something, because if we have a perfect square trinomial or we have a cubed function, we might have to pull out some extra factors for it first. So let's look at this first example. It says, using all the information that we know about regular simplification, the very first thing that we're going to do is we're going to pull out common factors, right? After we pull out common factors, then we will factor what's left over. But our first step is we're always going to look for common factors first. So on your notes, you can see that we've got this one in the 2 box with a couple of extra notes in there. So let's look at the top. 6k minus 36. Do they have anything in common?
6.
6. So if I am pulling that out, I'm undistributing, I'm factoring out, we're going to pull out a 6 and be left with
K minus 36.
K. Oh, so if I pull a 6 out of this entire group,
you'd just be sick.
yeah, because we always are asking ourselves, 6 times what gets me back to 36? So we're going to have a 6 here on the top. Okay, now, is there anything that these 2 terms have in common? No, so we're going to leave them alone. Now, they are not written with the parentheses, but it is understood that they are grouped together, so we can put parentheses around them. Now, where does the multiplication sign lie? Why don't you come put a multiplication sign on the...
Well, there'd be one. I mean, we assume that's multiplied by, right?
So that.
So right there.
Yep.
And then, is this multiplied?
Is this binomial multiplied by anything?
Is it by this one?
No, what is this sign here? What does this mean?
Oh, divide.
Divide. All right, so do we need to add any other signs? We've got a multiplication here, we've got division here.
I would think so.
Okay, so we can only separate parts that are attached with multiplication. So we can separate the entire 6 minus k from the 6.
Right. Okay.
Correct?
Yeah.
Okay, so what things are exactly the same on the top and the bottom that are a whole grouping?
Just these two binomials.
Correct. So the entire 6 minus k comes out,
Okay.
right? Because here's our multiplication. Whoops. Here's our multiplication spot. The entire one comes out, which means it has to cancel
That one out.
the entire one on the bottom.
So we just be left with 6 over 1.
Correct. And do we ever write over 1?
No.
Nope. So we're left with
6.
perfect, right? So what's important as we are doing these common factors, once we get to pulling out a binomial, is to use our parentheses to keep those together so that we're not accidentally trying to simplify something
That we can't.
that you can't. It needs to be the entire part. We've got to find out where's the multiplication. That's where we can break it off. And then that whole piece has to come down. Does that make sense?
Yeah.
Okay. So let's look at this one. The first thing we're going to do is we're going to look for common factors. On the top, y plus 8, are there any common factors that we can take out?
I mean, on 8 we could do we want to factor 8 all the way down?
Well, can we, remember this is attached, so we have a variable attached to a constant with addition.
Mm-hmm.
Okay, so if we're going to pull something out, it has to be by multiplication.
So no.
Yeah, multiplication or
Okay.
division. So if I'm pulling something out of 8, I would also have to pull it out
Of y?
of the y. So do they have anything in common?
No.
No, they don't. Now on the bottom, is there anything in common that we can pull out? So we are going backwards from distribution.
Mm-hmm.
Is there a common factor between all of these coefficients that we could pull out?
2, right?
Okay. That means I would have to take a 2 out of the coefficient of each term that's there.
And there's no coefficient for y squared.
Okay. So if our coefficient of y is 1, is there anything that we can pull out?
No.
Okay. So every time we see a coefficient of 1, what does that tell us?
It's simplified. Yeah.
There's no other common factors that we can pull out. Okay. So if we can't pull out a common factor, can we factor it a different way
Yeah.
to break it down smaller? Okay. Is this as small as it can be? Y plus 8?
No. It could be y plus 2 times 2 times 2, but
It could be.
there's
But
no point.
we have an addition sign here, right? So this is going to be written as a singular binomial,
Mm-hmm.
right? It's grouped together with addition and subtraction. We can't add a multiplication if we're not also multiplying the y.
Okay.
Okay? So on the bottom, how could we break this apart? Remember, because we like to have variables with a exponent of
1.
1. Does this have an exponent of 1?
No.
No. So we want to break it down so that it does have an exponent of 1.
So y times y.
Okay. How do we factor a quadratic? There are, when we were learning quadratics in chapter 5, and we were breaking them apart to find answers.
Mm-hmm.
Okay. There are several different ways that we could find an answer to get down to a singular y, correct? We could use the quadratic formula. We used completing the square on it. We used square roots, which we just did it in our last lesson, right? Or we just factored them. We unfoiled it, correct?
Yeah.
So can we use, we don't have an equal sign, so we're not solving for y. We just want to make it look smaller, okay? So when we make it look smaller, we are looking to unfoil it, right? Because foiling two binomials creates a trinomial. So if we go backwards, we can go from a trinomial to two binomials,
Okay.
right? So we always read these backwards because we're going backwards. We had started with two binomials to get here, so we're going to read it backwards to go here. So how do we read it backwards?
So it's what factors of 48, negative 48,
Yeah, what factors of 48
add up to, subtract to 2.
to equal 2? What factors of 48 subtract to be 2? So let's do our T-chart for 48 like we did before. So 1 times 48 is obviously not going to work,
Right.
right? We can have 2 times 24. The difference between those is not the same. So let's start thinking. We have 4 times 12. It's not there. Okay, what are some other factors of 48?
6 times 8.
6 times 8. Okay.
So yeah.
So we're looking for 2 that subtracts to be
2.
2. Did we find ones that subtract to be 2?
Yeah.
Okay. Which ones?
8 minus 6.
Right, 6 and 8. So they go in our binomials in the same order that we wrote them. 6 and 8. Now, is there a coefficient on the first guy?
No.
No, just 1. Right? So our y is set in there. Now we've got to figure out what the signs are. Okay? Our last sign tells us,
If they're what is it? If they're the same?
So are they the same?
No.
No, they are
Different.
different. Okay? And our middle sign tells us,
Is it that the positive comes first?
the largest number. So the signs are different. The middle sign, remember, it tells us that the largest number
Is positive?
is positive.
Okay.
The biggest number. So which one is our bigger number?
8.
So the 8 gets the
Positive.
positive and the 6 gets a
Negative.
perfect. All right. So now, instead of having y squared plus 2y minus 4, 8, we have y minus 6, an entire binomial, y plus 8. Where is the multiplication sign?
In between the two.
In between the two binomials. So the only place that we can break these apart is right here,
Okay.
between the two binomials. That means the entire section on the left has to go away, or the entire section on the right has to go away. Okay? Is there anything on the top and the bottom that match?
Yeah. The y plus 8.
Okay. So our entire y plus 8 matches our entire y plus 8 on the bottom, so they can be removed, and we are left with what on the top?
1.
1. Well done. And what is left on the bottom?
Y minus 6.
Y minus 6. Okay. So we are fully simplified at 1 over y minus 6. Remember, this y minus 6 is still one unit together. So this is not the same as 1 over y minus 1 over 6.
Right.
Okay, so the y minus 6 is one unit together. Okay, so let's do another one. Look at this. Okay, so on the top, is there a common factor between the coefficients? So our constants here.
No.
We have a 1 and we have a 49, so there's nothing that we can pull out. Let's look at the bottom. Between 7 and 1, is there anything we can pull out on the bottom?
No.
No. Okay, so we can't do anything with common factors. So now how can we break this apart and make it smaller? The top is p squared minus 49. Does this look familiar?
Yeah. Square roots.
It would be square roots if we had an equal sign, right? But we're not solving for p. We're just trying to break him apart smaller. Okay? So this was our perfect square, or our difference of squares. Remember? So we have a p squared. How could we rewrite 49 as a squared?
7 squared.
Perfect. 7 squared. So now we have p squared minus 7 squared. We have a difference of squares. Difference of squares unfoiled into a very unique format all the time. Right? So our first two terms
P.
are p. Okay?
And then one is positive and one is negative 7.
Excellent. So we put our last two terms 7 there, and then one is positive and one is negative. Perfect. Now on the bottom we have 7 minus p.
So we can
Where is our where can we break them apart? Where's our multiplication sign?
in the middle.
Right in the middle of these two. So this is where we can break them apart. Okay. Is there anything that is identical that we can pull out?
This 7? Or
Okay. Can we remove this 7 from the p?
no.
No, because
He's negative.
he's attached with an addition or subtraction sign. So we can't cancel these guys. They are attached with addition and subtraction sign. If we're going to cancel, it has to be, it's all or nothing.
The same.
It has to be all of it and all of it on the bottom. Now these guys look very similar, but are they the same?
No.
No, because this is p first minus 7, and the order with subtraction matters, right?
Yeah.
And this is 7 minus p. Is there a way that I can change one of these to look like the other one?
I mean, you could.
Okay, what
You
if
have to move them up to the top, so that
if we move it to the top, we take this exponent and we make it negative, right? So does that change our values?
no.
No. What do we want to change? We want to change,
The value of 7 or p or both.
yeah, we want to change their sign, right? Let's look at this one on the bottom, okay? I want it to, right now he's positive and the p is negative. But I want the 7 to be,
Negative.
I want him to be negative and I want the p to be
Positive.
positive. What value in mathematics changes the signs?
-1.
-1, right? So if I multiplied that guy by -1, then he would change both of them, right?
Yeah.
If I did it like that. Now, when we multiply one part, we have to multiply all of the other parts. So let's not think of it as multiplication, okay? What if we factored him out? Instead of adding something to the equation, why don't we already use what's in the equation and we're just going to extract it? Okay? So we know that we have to have a -1 would affect this guy. Okay? So we're going to take a -1 out of this binomial. Okay? So we're going to put a -1 at the front. We are factoring him out. Okay? So we have to ask ourselves again, -1 times what gives me 7? To get back to this.
-7.
-7. Okay? So we're writing it in a different way with a -1 up front. Making sense?
Yeah.
Okay? So again, we're just changing, this has a name, like this might have a name of Miss Thomas, and this is where my kids are calling me Mom. Okay, so we're just looking at it, same thing. We're getting to it, we've just broken it apart in two different parts, okay? So if I have a negative 1 on the top, how would I get back to a negative p?
Positive p.
A positive p. Okay? So we can take 7 minus p and we can switch their places if we factor out a negative 1.
Okay.
Right? So now, instead of having 7 minus p, we have negative 1 times negative 7 plus p. Do we like it in that order?
No.
Let's change it around. So we have negative 1 times
P minus 7.
p minus 7. All right? So 7 minus p is the same as negative 1 times p minus 7. Okay? Anytime we see a binomial and we want to change the places, if it's subtraction, now if it's addition here, does it matter what order we put those guys in? No, because we've got a commutative property with addition. But we do not have commutative property with subtraction. Right? Order matters. So if we want to change their place, we have to pull out a negative 1 every single time. Now, do we have something that's exactly the same on the top as it is on the bottom?
Yeah.
What do we have?
The p minus 7.
P minus 7 is exactly the same. So, what happens to this negative 1?
Does he stay on the bottom?
Does it matter if a negative 1 is on the bottom or on the top?
No.
No. Because 1 over negative 1 is the same as negative 1 over 1.
So you could just move him to the top and have p plus 7 times 1, which is just p plus 7.
Times
Negative 1.
times negative 1. Yep, so
But
we have,
does he not turn to a positive when he goes up top?
no, the things that change when we change the sides are our exponents.
Oh, yeah.
Not their values, their signs, okay? So now I've got negative 1 from this bottom part of our constant. He's attached with multiplication, right? And I've got p plus 7. So how would we get that back down simplified again?
Would we multiply by negative 1 again?
Uh-huh.
Okay. So it's just, then it just becomes 1 times p plus 7, right?
No, he has to be distributed.
Oh,
I know he's a 1, but if he was a 2, that makes it look a little different. He actually has to go in. Right? So negative 1 is on the outside. He's going to distribute to each guy. So negative 1 times p is
negative p.
Negative p. Negative 1 times 7.
Negative 7.
Negative 7.
Okay.
So we just have negative p minus 7.
Okay.
So on your notes, I have this little bubble. It says, watch out if we have a minus b over b minus a, right, in these terms, we cannot cancel them as is.
Right.
But we can swap places by pulling out a negative 1. And then it creates them in the same order, a minus b, a minus b. Okay? So which then would cancel, and we always get left with negative 1. So when we're changing their locations, we are pulling out that negative 1. We're making him visible. Okay. So he already exists in there. Negative 1 can exist into any equation as long as we're changing the signs. He's just that constant that we're not used to working with the 1s because we never write them. They exist, they stay there, but we don't ever write them, right? But we know that negative 1 times negative 1 equals 1. So he's really in there. We just don't usually see him. So if we're pulling out 1, we've got to leave the other one in there. All right? Okay, so let's look at this guy, because sometimes we've got a common factor and we have a factoring that has to go at the same time. Okay, so first step, common factors on the top. Is there anything that's a common factor that we can separate and pull out?
3.
Okay, so a 3, because 12 is really
3 times 4.
3 times 4. Okay, so I can take a 3 out of both of these guys and put him in the front. Is there anything else that I can take out?
Would it be one of the A's?
One of the A's, so I can pull this A out to the front. If I take an A away from 3 A's, how many A's do I have left? 2. So I'm going to pull an A out, and I get left with A squared. So now we have 3A on the outside. What's left from our 12?
4.
4. How many A's are left?
2.
2 A's are left. And what's left on this guy?
Just 3. Negative 3.
Where did the 3 go?
Out.
He had to go out to the first place.
So there's nothing.
Is it nothing? Is it 0? Or is there something else?
It's a 1.
It's a 1. Okay, so now we're going to double check ourselves. Whenever we're unsure, we can always distribute back. 3A times 4A squared gives us
12A cubed.
12A cubed. Exponent rule, when bases are the same, we do what to the...
Add.
We add them. So 1 plus 2, perfect. Now, 3A, if this was 0,
It'd be 0.
then we would have 12A cubed minus 0. Is that what we have?
No.
No. So that's a good way to check that 0 is not the right answer. We have 1, so 3A times 1.
It's just negative 3A.
Yeah, negative 3A. So we're back to where we're at. We've confirmed that that's true. So then on the bottom, do we have anything that we can pull out of these guys?
Yes. 6.
So we can take a 6 out. What's left in 12 if we take out a 6?
2.
2. What's left here at the 6 if we take out a 6?
1.
1. Okay. What else can we pull out of them?
2 A's.
2 A's. Okay. If I take 2 A's away from 3 A's,
2A. You just have 2A.
I started with 3. I took away 2.
So you just have 1A.
I have 1 left.
So just A.
I started with 2. I took away 2.
0. None.
I have another 1.
Okay.
Correct?
Right.
Okay. So what do we have left? We've got a 6A squared on the outside. That's our multiplication. And what do we have left over?
2A plus 1.
2A plus 1. Okay. So we check it when we go back in. Distribute it. 6A squared times 2A gives us
12A cubed.
12A cubed. And then 6A squared times 1.
6A squared.
Okay, so now we know we're good. Pulling out factors, okay? Is there anything that we can cancel, top and bottom, so far? Is it all, are we down to singular variables with a single exponent?
No. I mean, we could probably...
There's stuff over here that we can simplify.
Right.
But is the top fully simplified yet? Is it fully factored out?
No.
No, what do we have here with 4A squared minus 1?
I guess 4 can factor down.
Okay, we could rewrite 4 as what?
2 times 2.
Okay, or 2 squared,
Mm-hmm.
right? Oh, how could we write 2 squared times A squared?
2A squared.
2A, the whole thing squared, correct?
Mm-hmm.
Minus 1. 1 can have any exponent, correct? Because it's always the same. So 1 squared. What do we have now? We have a difference of squares.
Okay.
Okay? Difference of squares unfoils or factors to what? Every single time.
Different sign?
They have different signs. So what are the first values?
2.
2 what?
A, 2A.
It's the entire space, 2A and 2A, because that was our squared value.
Mhm.
What's in our second term?
-1 and +1?
Yeah, 1 and 1 is negative and 1 is positive.
Mhm.
So let's check ourselves. We said that we had 4A squared minus 1, correct?
Mhm.
2A times 2A for firsts, FOIL, right? 2A times 2A gives us
4, or
4,
A squared.
4A squared, okay, check. 2A times 1
2A.
is a positive 2A. 2A times negative 1,
-2A.
negative 2A, so those cancel,
Mhm.
right? And then 1 times 1,
Well,
or
it's
1 times negative 1,
-1.
gives us negative 1, okay? So we've confirmed that our factoring is correct. So now, instead of having 4A squared minus 1, we are replacing it with 2A minus 1 and 2A plus 1, right? Now, we've gotten our exponents down to 1, so there's nothing else that we can break apart with factoring. We have multiplication everywhere. We have our dotted line, right? So what are the sections that we can cancel out?
The 2A plus 1.
2A plus 1, the whole thing
Mhm.
can cancel with what?
Can cancel with a -1? Or what,
Remember, we are looking for something that's exactly the same on the top as it is on the bottom. We're trying to create holes so that they make the number 1 and we can not write them down anymore.
it just cancels the 2A plus 1 on the bottom.
Perfect. So I have an entire 2A plus 1 on the top. It cancels the entire 2A plus 1 on the bottom. Is there anything else that can simplify from the top and the bottom?
3A and the 6A's.
Okay. So how can the 3 and the 6 simplify?
Could write out A squared is A times A,
Okay,
and then 6 is 3 times 2.
perfect.
So you could cancel out the 3 and the A on the top,
3 on the top, 3 on the bottom.
and then 1A and 1A. So
Okay.
you just have 2A left on the bottom.
So what is left on the top?
2A minus 1.
2A minus 1. What is left on the bottom?
2A.
2,
Or A.
yeah, 2,
2A, yeah.
and all of the rest was canceled out. Okay, now, can I cancel those guys?
No,
Why?
because they're not being multiplied.
Because this guy here is attached with a subtraction sign, so he is not free to go.
Mm-hmm.
Okay? So we would leave our answer as 2A minus 1 over 2A.
Okay.
Okay? We can never take something out if he has an addition or subtraction sign attached to him.
Okay.